Hi everyone, I'm Sherin and I will be presenting our work HierarQ, task-aware hierarchical Q-Former for enhanced video understanding. Current multimodal models have shown strong performance across several different tasks, but as video grows longer, these models start facing challenges due to LLM's context length limitation or even input frame processing limitation. Existing strategies like frame sampling or coarse token compression without task-level awareness can help reduce token loads, but they also risk losing key temporal information, especially in longer videos. To address these, we introduce a task-aware hierarchical querying transformer-based framework that processes entire video autoregressively without requiring frame sampling or hitting the LLM context length bottleneck. Additionally, we incorporate task-level awareness by dynamically emphasizing relevant details based on task requirements. Here we see an example of our model adaptively focusing on task-relevant segments based on the given prompt. Now, our framework supports autoregressive processing, which means that it processes the entire video sequentially instead of traditional batch level processing. It uses two-stream language-guided feature modulator to incorporate task-level awareness. The entity-guided modulator captures relevant entities within a shorter window, whereas the prompt-guided modulator captures their broader scene-level interaction over a longer window. The modulators contain cross-attention layers to modulate visual features according to the entities or the whole prompt to respectively extract entity-relevant or scene-relevant visual features, which are then stored in dedicated short and long-term memory banks. Now, these memory banks enable our proposed HierarQ to model long-term relationship that captures both entity-level and scene-level details. Lastly, the output from HierarQ is sent to an LLM to generate the response to the given query. Now, HierarQ itself consists of two different Q-formers. One is entity-level, the other is scene-level. And both of these Q-formers interact with their own dedicated memory banks, as we have seen before. And each of these memory banks contain two different types of memory to store their previously seen information, which are the visual memory, which stores modulated visual features, and query memory, which stores previously learned queries. When the memory bank exceeds in size, the short-term memory is updated via FIFO, and the long-term memory is updated via compression based on similar tokens, which are further used for processing. Now, each of these Q-former also have their own set of learnable queries, which consists of 32 tokens. The learnable query self-refines itself through a self-attention layer, where the query comes from the current set of learnable queries, and the key and value comes from the query memory bank, which contains previously learned queries. Then, it aligns itself through the visual feature using a cross-attention layer, where again the query comes from the current set of learnable query, and the key and value comes from the visual memory bank containing information about the past frames. The learned query of the entity-level Q-former interacts with the scene-level Q-former through another cross-attention layer to complement the scene-level Q-former's understanding. Thus, the scene-level Q-former's learned query captures broader scene-level information through the scene-level Q-former, which are complemented by entity-level information captured by the entity-level Q-former. Here we show performance of our model across several video tasks. Here our model achieves state-of-the-art performance on long video understanding on the LVU dataset and short video understanding on breakfast and coin dataset. Additionally, it also achieves state-of-the-art performance on short video question answering on MSR-VTT QA, MSVD QA, and ActivityNet QA dataset, and also long video question answering on the MovieChat 1K dataset. And lastly, it also achieves state-of-the-art performance on video captioning on MSR-VTT, MSVD, and UCook2 datasets. Here we see that as the short-term memory bank length increases from 10, the performance starts decreasing, which is likely due to the fact that excess entity-focused information starts overshadowing the scene-level context, reducing its complementary role. On the contrary, for the long-term memory bank, as its size grow over 10, we see that the performance starts plateauing, which might indicate that retaining all historical data is essentially necessary due to the temporal redundancy. Thus, we select a memory bank size of 10 frames, where we store 32 tokens for each frame. Now, as we can see here, that HierarQ maintains a constant memory consumption, processing over 10,000 frames on only a 24 gigs GPU. Unlike other models with computational growths, HierarQ's autoregressive design ensures scalability. On the other hand, due to the very same autoregressive processing, while latency does increase linearly with the number of frames, HierarQ still remains capable of processing arbitrarily long videos, unlike other models that might fail beyond a certain frame threshold. Here we highlight the HierarQ's subtle event identification capability. For example, in this video, we see that the appearance of whale occurs in only a few frames, which other models might miss due to coarse compression without task awareness. HierarQ also effectively detects the absence of stars, thus avoiding the potential bias that might be present in other models' association of Earth with stars due to the video content being focused on the planet's view from space. Moreover, HierarQ is Also robust to implicit identities. For example, in tasks like video captioning, generic nouns such as video can serve as entities, enabling the entity-guided modulator to modulate the entire video. In cases where no entities are present, modulator returns the raw frame features to the short-term memory bank, ensuring adaptability. Lastly, for multiple non-distinguishing entities like man, woman, or character, the modulator processes all, while HierarQ prioritizes relevant relationships using the scene stream and long-term memory, and thus retaining superior video understanding capability. Thank you for listening. If you find our work interesting, please visit our project page.